This is the video for the lesson which discusses double and half angle formulas. So in the previous lessons we were talking about sum and differences. We can kind of use those to a large extent to prove the double angle formulas. So what we end up with here is if again, we said we can't distribute things inside or outside of a trig function. So what we have here, we have sine of 2 theta is going to be 2 sine of theta cosine of theta. And again, if you went back and made this sine of theta plus theta and use the sum formula that we had from the previous section, you would see that you end up with sine theta cosine theta twice, which you can add together to get 2 cosine theta. For cosine of 2 theta, there's a couple of different versions you can end up with. Again, what you end up with the if you were to convert this to cosine of theta plus theta, and again plug that into the sum formula that we had before, you end up with 2 cosines, so cosine squared, and sine times sine, which is sine squared, and again you're going to have a subtraction between those two. So that's what we end up with here. And then if we go back and use some of the Pythagorean identities that we talked about in the first section, you can either rearrange this to be 2 cosine squared minus 1, where you're replacing this sine squared with 1 minus cosine squared, or similarly, if you replace cosine squared with 1 minus sine squared, you can end up with the formula that we have in the third line. All three of these are equivalent. So it just is going to depend on which trig ratio you have as far as which one you want to use. Notice in sine, you have to use sine and cosine, but you actually have an option down here with cosine. You can just be given cosine or just be given sine and be perfectly fine to figure out what cosine of 2 theta is. Finally, tangent of 2 theta, again, if you plug that into your sum formula from before, you get 2 tangent of theta over 1 minus tangent squared theta. Again, the half angle formulas are a little bit more challenging. You notice we have these square roots in here. Sine of theta over 2, you end up with plus or minus, and so we're going to have to be very careful, and we'll talk about how we can figure out if it's going to be positive or negative in a minute. But we end up with the square root of 1 minus cosine theta over 2. Very similar. Cosine theta over 2 is plus or minus the square root of 1 plus cosine theta over 2. And I believe this is the one that in the back of your textbook, if you're trying to look at the formulas on the back cover of your textbook, one of these is incorrect. So please use the formula sheet that I provided. Tangent of theta over 2, you end up with 1 minus cosine theta over sine of theta. So I mentioned here we've got this plus or minus here, and really if we go back and talk about quadrants, we've got quadrant 1, 2, 3, and 4, and we remember that everything is positive in quadrant 1. Sine of theta and likewise cosecant of theta, because it's its reciprocal, are positive in quadrant 2. In quadrant 3, tangent of theta is positive, and cotangent of theta, again because it's its reciprocal, is going to be positive. And then finally in quadrant 4, cosine of theta and secant of theta are both positive. So what we have to pay attention to here now is that once we divide these angles in half, where does that throw the half angle? So if you originally had an angle somewhere here in quadrant 1 between 0 and 90, 90 is the biggest you can have, or pi over 2, whichever way you want to call it, then if you cut that in half, the biggest it can be is 45. So this is now theta over 2 is kind of its quadrant 1 or octant 1 if you want to call it that. And again, this is going to put you, if theta was between 0 and 90, then theta over 2 is going to be between 0 and 45. And that makes sense, you're just cutting things in half. Similarly, if you end up over here in quadrant 2 to start off with theta, you divide that in half. Well, we said if we're at 90, it goes to 45. If we're at 180 and we cut it in half, we end up at 90. So if we are talking about it, this kind of ends up being your octant 2 I call it an octant because we're dividing into eighths now instead of quarters. So this is going to be octant 2, so this would be where theta over 2 is going to be. If you start off with theta between 90 and 180, then theta over 2 is going to be between 45 and 90. And so forth and so on. If you were in quadrant 3 and you divide those in half, you end up here in octant 3. And again, this would have been if your original theta was between 180 and 270. Then you cut that in half, you've got it's going to be between 90 and 135. And finally, octant 4, if your original angle was between 270 and 360, then that's going to put you between 135 and 180 for half of your angle. So that's going to come into play. That's going to be able to tell us whether we're positive or negative. Again, sine is positive in both of these quadrants, but cosine is negative over here in the second quadrant. So we got to pay attention to where our angle would have ended up. So let's take a look at an example. Suppose we know that cosine of theta is equal to 1/2. And I'll kind of scroll here. Let's find cosine of 2 theta and cosine of theta over 2 using our formulas. So cosine of 2 theta, again, we've got all of these different choices that we can choose from. We're given cosine of theta, so let's just go ahead and pick this formula right here. We can go through and find sine, and we're going to have to in some cases, but for right now, let's not worry about it. So cosine of 2 theta is 2 times the cosine squared of theta minus 1. And if you want to rewrite that as 2 times cosine of theta squared, just so you remember what's going on here, that's fine. Again, we know that cosine of theta is 1/2, so we're going to substitute that in. And then we can simplify, and we get 1/2 squared is 1/4. 2 times 1/4 is 1/2. 1/2 minus 1 is negative 1/2. So this ends up being our ratio for cosine of 2 theta. And again, what you're really looking at here, this kind of makes sense depending on which angle you're at, but you've essentially rotated a full another angle around the unit circle, and so that's where you end up with a new angle, negative 1/2. So more than likely this angle started off in quadrant 1 and this one ended up in quadrant 2 when we doubled it. Again, these are ratios, not angles, so this is the ratio you get when you double the angle and take the adjacent over the hypotenuse. Similarly, if you want to find cosine of theta over 2, let's look back at our formulas. Cosine of theta over 2 is plus or minus the square root of 1 plus cosine of theta over 2. So again, we're going to substitute in. We know that cosine of theta is 1/2. So we've got 1 plus 1/2 over 2, still all under square root, plus or minus square root of 3/2 over 2, which is plus or minus square root of 3 over 4. Again, remember how to multiply fractions. This would be 3/2 times 1/2, which would get you your 3/4. And again, this is can be simplified a little bit more. We get plus or minus the square root of 3. We can take the square root of 4, which is just 2. So we can take that out of the radical by performing that operation. Now, something to kind of keep in mind, as we mentioned before, is that if theta had been in quadrant 1, then when we take half of that angle, we're still in quadrant 1, so we'd get that positive value. So if theta had been in quadrant 1, again it's positive, so we know it was either in 1 or 4, then cosine of theta over 2 is positive radical 3 over 2. Whereas if theta had been in quadrant 4, again, that's where cosine is positive as well, then cosine of theta over 2 would be negative, because if you think about splitting it in half, going back up here, if we had been in quadrant 4, if we split it in half, we end up in this orange scenario here, or yellow, whichever one it kind of shows up as, this orange scenario here, where we end up in quadrant 2, and again, cosine is negative in quadrant 2. So now that we've done an example, I want you to pause the video here and try part A of this next example. Okay, so for this one, you should have ended up finding that cosine of 2 theta is equal to negative 7 over 25ths. And if you did not get that answer, go back through and look at the steps that we have here. Pause the video if you need to, and go back and see where you might have made a mistake. Again, remember that when we split up the squared here, the 2 is not squared, only the sign is squared. So let's look at another example here, sine of 2 theta. Now if you remember the equations for sine of 2 theta, sine of 2 theta is equal to 2 times the sine of theta cosine of theta. And in this case we have sine of theta, but we do not have cosine of theta, so we need to find cosine theta. We have cosine 2 theta, but not cosine theta. But we can easily find that because we know that all of these can be reduced down to triangles, and we can find the remaining leg of the triangle that we're missing. So if we think about a right triangle, we have theta here. Sine is opposite, so this would be our height is 4, our hypotenuse is 5, and if you recall, that would give you a 3, 4, 5 triangle with your base being 3. Again, you can use Pythagorean theorem to go through and find this as well if it's not one of the easy Pythagorean triples. So in that case, cosine of theta is actually going to be adjacent 3 over hypotenuse 5. So we can plug these in now. We have 2 times the sine was 4/5 and the cosine was 3/5. So multiplying those out, we end up with 24 over 25. Again, 2 times 4 is 8, times 3 is 24, 5 times 5 is 25. Again, you can think about this number 2 out front as 2 over 1. So that's what we get for the sine of 2 theta. So again, if we doubled that angle, we end up with a new ratio of 24 over 25. Finally, if we want to find sine of theta over 2, we get plus or minus the square root of 1 minus cosine theta over 2. And again, we've already found cosine, so we can plug that in. Plus or minus the square root of 1 minus 3/5 over 2. So we get plus or minus the square root of 2/5 over 2, which is plus or minus the square root of 1/5. If you do not like to leave things all under the radical, technically this is plus or minus 1 over the square root of 5, because we can take the square root of 1 as 1. If we do not like to leave the radical in the denominator there, we can rationalize it by multiplying by the square root of 5 over the square root of 5. And we end up with plus or minus the square root of 5 over 5. And again, if we had known what quadrant we were in to begin with, we could determine whether or not we have that positive or negative. So with that in mind, we have that same sine of theta is 4 over 5, but now we're saying we're in quadrant 2. So sine of 2 theta is actually not going to change at all. This is still going to be our 24 25ths that we found up above. Cosine of theta over 2, now we can find what that will be. Cosine of theta over 2 is, again, using that formula. We haven't done this one yet. It's going to be plus or minus the square root of 1 plus cosine of theta over 2. So this is equal to the square root of 1 plus, we said cosine was 3/5 over 2. So we end up with plus or minus the square root of 8/5 over 2, which is plus or minus the square root of 4/5. Again, we can take the square root of 4 and get plus or minus 2 over the square root of 5. And again, if we wanted to rationalize the denominator, we multiply by that square root of 5 over 5. And we end up with plus or minus 2 root 5 over 5. Now again, looking back up here, we know we were in quadrant 2 with sine, so when we cut that angle in half, we end up in quadrant 1. And so in that case, we know we just have a positive value. So this is going to be positive because theta over 2 is going to be in quadrant 1. And make sure that makes sense. If we were in quadrant 2 to begin with, that means when you cut the angle in half, we ended up in quadrant 1. So we know this is going to be a positive value. Finally, sine squared is actually pretty straightforward. All we're going to do here is square the 4/5 that we had. And that is going to come out to be 16/25. So I want you to pause the video here and try example 35 on your own. So for this one, again, you need to draw your triangle to find cosine and sine so you can plug things in. They told us we're in quadrant 4, so we can draw the triangle down here. Our height, if you will, is -3, and our base is 4. Again, our hypotenuse would be 5. Again, plugging into the formulas, cosine 2 theta, you have some options. This was just the one I chose, and I ended up with 7/25. No matter which equation you choose, you should end up with 7/25. For sine of 2 theta, we end up with -24/25, and for tangent of 2 theta, we end up with -24/7. Again, we got to have some practice with fractions there. So let's take a look at a couple more examples. For this next one, we've got we want to find tangent of 2 theta when cosine of theta is -12/13 and theta is in the third quadrant. Again, we know the formula for tangent of 2 theta is going to be 2 tangent of theta over 1 minus tangent squared of theta. That's the one we just used above. So we need to find tangent here, and we only have cosine. Again, we're going to go over here, we're going to draw our angle. It tells us we're in the third quadrant, so we're down here, and we can make our triangle. We've got cosine, which is adjacent over hypotenuse, so our -12 is here on the x-axis, and the 13 is our hypotenuse here. And then this is another one of the Pythagorean triples. You find that this side here is 5, but again, we're down here in quadrant 3, so this is -5. So if we put this all together, we find that tangent of theta is positive 5/12. So -5 over -12, which would reduce to be 5/12. And so now we can come back over here and plug this in. So we've got 2 times that 5/12 that we just found over 1 minus the 5/12 squared. So we'll simplify a little bit. 2 times 5/12 is 5/6, because again, 2 divided by 12 would leave you with 1 and 6. We got to square this 5/12 in the denominator, so we're going to end up with 25 over 144. Now we need a common denominator. We end up with 144 minus 25, which is 119 over 144, and now we can multiply by the reciprocal, so 5/6 times 144 over 119. Again, we've got simplification here. 144 divided by 6 is going to give us 24. That's all it's going to simplify. So we've got 5 times 24, which is 120 over 119. So this is tangent of 2 theta that we have found. Again, with our formula, knowing nothing about tangent to begin with, knowing nothing about what angle we have, just all we want is the ratio. Again, tangent is opposite over adjacent. This is going to tell us those two ratios of this new angle 2 theta.